Okay. So I'm going to share this screen. Can you see?
Yes, sir. Yes, sir.
Hmm. So before this, what I have done, I have already made the schematic, okay, and its corresponding symbol, right? So I'm opening the schematic and test bench as well. Also, I have made, okay. So in test bench, there is no X and Y and all those things. It's as it is simple test bench is been made. If time permits, we will do the post layout simulation. After that, in that case, we will need this test bench. The same test bench you have done. Okay. So I am opening this schematic. Uh, uh, by the way, we are doing this on UMC 180 nanometer technology. Okay. So here, before this, whatever you had used, like in PMOS, you might have used the W is equal to Y here. Okay. So just erase that. I have put this 480 nanometer and the width of NMOS is 240 nanometer. It is for layout construction. The width of PMOS should be double than width of NMOS because for better what you can say um, better connectivity, not connectivity, but better imposing on into each other. After this, from this schematic layout window, a schematic window itself, I am going to launch the layout Excel. Okay. Again, keep it as default. Hmm. So this is your layout symbol. See here in layout symbol, you have different layers as well. The PDEF, NVEL, PVEL. Okay, all these layers are also there, as well as metal layers are also there. M1, M2, ME1, ME2, as well as PO1, PO2, poly layers are also there. Okay, so before starting, you have what you need to do. You need is uh, to learn about some controls. Okay, with your mouse scroll, you can zoom as well as unzoom. Okay, with key F, you can just fit to screen to measure the distance between two nodes. Okay, see the ruler you can get using pressing key K. Okay, K, the key K. You can do that, and to escape all this, escape and delete. Okay, because these all the things you will need. Again, one thing you need to do is in go to options, and initially this was 0.1, 0.1. Okay, but what I need is X snap and Y snap. When I move the objects when I move the objects in that layout editor, I want it to be as minute movement as possible. Hence, I am editing this 0.005. Okay, and okay. This should be 0 to 31. If it is 00, even if it is 00, that is okay. Okay, we'll start with 00. Okay, 00. Now just add the instance. How you add the instance? By pressing I from keyboard or by clicking on this. So from UMC 180 nanometer NMOS of layout. Okay, the layout we want. See here. Total width is 480 nanometers. So NMOS we are having of 480 nanometers. Hence we will not change that. And I am just placing this here. Okay. I have just placed this by clicking it. Now to see what inside this, either what you do display 30. Okay. So you can see inside of this, or you can just press Shift F. By pressing Shift F, you can get the inside structure. Okay. So what are different layers that has been used to construct the NMOS? You can just see by clicking here. Okay, it will display only used layer only. So this is NMOS. I want a PMOS as well. So in here only the PMOS is there. So there is a PMOS. So I'll just see. So total width here is 480 nanometers. Okay. So I don't need to do anything here. And here, it's okay. 240 nanometers. It should be same as you have taken it in schematic. Okay. Now, just open the schematic. There you will see. Just open the schematic. See here. Uh, See here. What we need to do? We need to connect poly to poly, source to one of the drain, and then some VDDs and VSSs. Okay. So this poly is the source, right? Hello. Uh, can,
Yes, sir.
can you listen clearly, na?
Yes, sir. Yes, sir.
Uh, okay. I don't need this. Okay. So what we need is we need to first align this over each other. Okay. So are they aligned perfectly? Like if it you want to see an imperfect alignment like this will generate the DRCs. Okay, this will generate the DRCs. So what you need to be like this at this exact. Okay, now wait, किसी का माइक मैम माइक और आवाज भी बंद इको आ रहा था. So now just press M and click once only and just move. Okay. Again press M and move. I am keeping this much gap here for this connection. This connection. Okay. And this connection. In connection and out connection. Okay. Now let's connect these things. So how do we connect these things? Okay. By using poly, because this is the poly, right? By using poly and press the R. R means rectangle. Okay, shape rectangle, right? So press R or create shape rectangle. So from here, I will click only once and move the mouse. I will click second time at the place where I want to release this, like here. Okay. Now see here. This will again generate some DRCs. Okay. This will again generate some DRCs. I will leave how you can minimize this by pressing S stretch. Okay. Now it's perfectly aligned, right? Okay. So save this. Now what you need? You need the this connection. Source to drain. Okay. You need this connection. So I am just gonna connect these 2 points. Okay. Using metal one. Here I am just clicking on metal one and pressing R, that is rectangle. From my mouse, I am clicking just once, moving my mouse and releasing it wherever I want. Okay, by clicking second time. Most of you will means click double click. Don't double click while drawing that rectangle. Okay. Now again, I need this from P. I need this connection as well, right? This one, I need this one as well, right? So okay. Now I need the wire which wire from metal one to poly. So I am just creating this wire from here. Create wire, and which one? M1 to poly. Okay. So M1 to poly wire is there. So I am just putting that wire here only by clicking once. Okay, it's good. Now what I need again ME1 for these connections, VDD and VSS. Okay, so again I am doing like this. C means copy. Okay, by typing pressing the key C on your keyboard, you can just copy anything. So C, and I am clicking on this like this. Okay, now M, that is move. M for move, C for copy, K for ruler, R for rectangle. Okay, now this whole whatever you the black thing you are seeing is nothing but your anvil. Okay, so what I need is again I have to create a via M1 to PDF to put it here. I don't need this much metal, so I am reducing it. I need again one wire here also, so I am creating again one wire M1 to anvil. And I don't need this much, so this is okay. I'm just gonna save this, right? Yes, I'm just gonna save this and we'll see what DRC errors are occurring. Okay, just to let you understand, I have means I have put some DRC errors here. Means I know where are they. So let's see which DRC errors. How you go? How you check the DRC is by clicking Ashura. Here run DRC. Okay. Now at the beginning you might not have this one. Okay, this one clicked, or you might have this one undefined, so you have to do this and DRC. Okay, so this rule file will appear, and now just click OK. So there are different errors are there. Let's see which are there. How to see which errors are there? So I am clicking one error here and I am pressing here. Okay, preview the next error. So here I can see that this error. What error is that? Just see, minimum equal potential annual spacing is 0 micrometer or greater than 0.9 micrometer. Okay, so this can be either 0 or either it can be greater than 0.9 micrometer. How much it is can we check by pressing K. I am just checking the error. See, this is 0.025, which is not fine. So what I am doing, I am just moving this block to nearer. I am just diminishing this gap. Okay. Okay. Now again I'll save this design and again I'll check the DRC error. If I'll check if that error, same error is uh, mitigated or not. Okay, okay. Now that one error is gone. Only one error remains. So where is this? Minimum poly width is 0.18. So where is this error? See, here is this error. So we know that poly width should be 0.18. So if I can see this, this is exact 0.18. Okay. Now I want to check this. This is less than 0.18. Okay. So it should be minimum 1.8. Okay. It is not saying that it should be exact 1.8. It should be minimum 1.8. So I can stretch this by, by pressing S, and at one of the edge I'm just pressing this. Okay. So this is it. Save this and again run DRC. Let's see if all the errors are gone or not. See, no DRC errors found. Okay. So now our design is DRC clean. Now next step is LVS, that is layout versus schematic. Checking the layout versus schematic. For that, what you need is you need to put the pins in your layout. So what you need to put the pins. So this is the pin, right? So creating the pin, what is the pin and what names you should give to the pins? The same as schematic. In your schematic, what are the names of your pins? Input pins, input pin is in, output pin is out, and VDD and VSS, that is VDD and ground pins are VDD and GND. Type of pins are also important. Okay, so here you can see the input pin, output pin, in-out pin, input output pin. So that thing you need to take into the consideration. So I am giving input pin as this in, hide, hide. mm, Wait, input pin. I am just putting a square shape here. Okay, and escape. Now I am giving the label in. Okay, so this is giving the pin as well as giving the label at one time. Now next, again I am going to give out pin. It is an output pin. Where should it be? Here is the output pin. One click, make the rectangle, and second click. Again, label, out. Okay. Now VDD. Here input output pin. VDD is input output pin. So again and again label, now ground pin, again it is a type of input output pin, and again label, remember you need to give same names. Okay, you need to give same names. Yes, this is how it looks, your design. Now next is nothing but your LVS, run LVS. Here again, when you have, you will open this LVS, you will have to click on this technology, define the technology, and rule set is LVS. Okay. So, okay. So see here. Okay, zero errors, zero warnings, whatever extraction and zero mismatches. So what if I will delete this and I will delete this, okay, and now I will run the LVS. Then you will able to see the errors as well. So how the error window appears? See here. As you can see, one unbound pin. Okay. In summary, which pin is out? One pin is not defined. Hence, now we will define that pin. How? Out, out, output. Labeling it. Hide. Okay. Now this is save this and again run LVS. Okay. So this is up to LVS. Now next is parasitic extraction. Okay. Next is parasitic extraction. So
Amol,
parasitic, yes.
I think let them do up to this point. Facts, let them understand up to this point. This DRC and LVS concept, if they are through, then we can tell it will be good. Otherwise, it will be too much together.
Okay, sir. So you can log
So,
into our systems and see do this thing one by one.
I joined a little late. So everybody understands the meaning of these terms DRC and LVS? So in the beginning, Amol, this students are aware of this DRC and LVS. What is this?
I told them that design rule check and layout versus schematic rule check. So how it
Okay.
works also, we had told you that there are some design rules which are defined for particular technology. Like as we had this error in here that poly width should be minimum 1.8. Sorry, should be minimum 0.18. This is for this rule is defined for 180 nanometer technology. So like this, so many rules are there, and while running the DRC, we put this rule file so that it can check from this rule file. Your design is you whatever you have designed, that you have designed as per this rule file. So this is how the DRC is been checked. Similarly, the LVS, that is layout versus schematic. So the layout and the terminals in pin terminals of layout and schematic are checked, as well as the uh, widths widths of PMOS and NMOS. All these things, which are the things are there.
And the file extension names generated by these uh, DRC and LVS files.
DRC and LVS files.
Yeah, extension of this the schematic file, the name of the schematic file, the extension, and the
.sch.
right, and this for LVS for this layout.
Uh, Not. I can't recollect the exactly
Okay, fine.
for the layout.
So, for all these students to understand that these are the two files at two different abstraction levels, and these abstraction levels should represent the same thing. That is the idea of LVS. And the file names obviously are different, so you are just telling that the information in both the files is one and the same thing. That is layout versus schematic. And after that, what Amol will tell about this parasitic extraction, because these are the unwanted portions of resistance and capacitance which is introduced but which is not intended. So that is, so I think let them do it, and then you can tell. So by that time they can digest. Or I think is it simply one or two click? If it is simply one or two clicks kind of thing, then you can go ahead with this, and then they will do it together.
Okay, sir. QRC is 1 or 2 clicks away,
Yeah, yeah.
and
PEX for PEX.
that is PEX is 2 or 3 clicks away, and that post layout simulation maybe they can do afterwards.
Okay, fine. So finish with that then.
So the parasitic extraction, what you need to do is go to QRC, set up QRC, and here you have to check the first it will be undefined. You have to check this UMC 180 CMOS. Okay, and from Ashura run Quartus QRC. so, so here one technology will be there only. Uh, Output should be extracted view. In extraction, in reference node, you need to put the VDD. In QRC net, you need to put the VDD because it will not be there when you open this first time. Okay, I had done this. That's why it is already present here. Now in netlist, sorry, in filtering, enter the power net and enter the ground net. Okay, so enter the power net is PDD. Now ground net is our GND, I think, right? It's GND, na? Yes. In earlier design, I had it VSS. So now it is GND. Okay. So rest of the options are same. In extraction, extraction type is RC. Reference node here, initially reference node, it will be a GND here, but you need to change it to VDD here and QRC nets VDD. So let's see if I get the result. Okay. This happened last time also. Okay, I forgot to tell you that you have to set up this directory from Ashura and LPE. You can take a screenshot. Okay, from here you need your directory should be same. Okay, CAD work Ashura LPE. Before this, your ID will be here, mtech whatever. This is my ID, that's why. Now let's see. Okay, Quartus QRC run is completed. Now I'll close this. I'll close this. Uh, I will close this and I will close this as well. Now in library manager, see, in library manager, what you had first, you had a schematic, you had layout, and you had symbol. Okay. Now what you get, what you will get, you get the AV extracted. Now let's see what is AV extracted. See here. The capacitors with the your NMOS here in PMOS. Okay, and some capacitors are added. Right now there is only one capacitor, but when we will do the post layout simulation, there you will see the how many total number of capacitors, resistors are being added to your design. So this is how you do the parasitic extraction. You log into one of our systems and one by one you can try. Okay. You can ask Preeti ma'am to for login password. Any questions?